not numerical. I mean, if you argue that the seasons are continuous, then tell me what season is in between summer and fall. What season is that? And then what's in between that one and summer? And then what's in between that one and the other one? And So no, they're not. I mean, they flow into each other, and you can talk about it's early summer, or it's, like us, it's winter summer, right?
Spring.
That would get confused though, like.
Yeah, exactly. So it's not really. The only thing that's really going to have that's touching is going to be numerical data. That's truly a scale to it. So if I say spring, then I don't want anything between it and summer. Blah, blah, blah. So the only time you're not going to have gaps in between is if it's numerical, where the scale means something, where a gap would mean I left something out. Now, if I look at this, would somebody go, "You left out between spring and summer"? No, I didn't. There's nothing in between. There's nothing there. I don't need to like put them together to show I didn't leave anything out, because this is spring and this is summer, right?
You get confused because of how we have to do the 0.5.
Oh yeah, I agree with you. I don't like that way, to be honest. But again, that's the way that most books do it nowadays. Back in my day, we didn't do it. But the other way is better, I think, is just to help for students that really didn't do well with algebra, because they get freaked out about the inequalities and the x's, and that's too bad. It sucks, because that's the best way to do it, really. Yeah?
So we can make corrections on the quizzes, right?
Yes, good. All right. I forgot to say it before, but yes. Remember? So one reason I do that is to alleviate some anxiety when you first take it. So hopefully you really represent what you know. But when you get it back,
How high of a score can you get?
so if you get an 80 or above, you can get 5 points back max, up to 100. So if you get it back and you get an 88, you can get up to a 93 if you do all the corrections and get them all right.
What if you get like a 50?
Okay, so if you got below an 80, you get a point for every 4 points you missed. So like if you got a 68, how many points did you miss? 32. What's 32 divided by 4? 8. So if you got a 68, you could get up to 8 points back. If you do all the corrections, get them all right. Does that make sense?
You say you don't work with points.
So every 4 points.
You said
it. So on a test, you will get 80 points, 88 points out of 100. Yes. I don't make the midterm 1,000 points and the quiz is 50 points. That's bullshit. Is that cool? Is that all right? No? Long story short, correct your stuff. And they're always going to be due the day of the next test. You with me? So when I give you the quiz back, it's going to be due, the quiz corrections are due the day of test 1. I like it. Talking about quizzes, let's have another one. Monday.
We're barely recovering.
Huh?
We're barely recovering from this. No, just,
It's too bad.
okay.
You're going to have to go get some, I don't know what you get for a supplement to help you recover from that. But,
Yeah.
Monday, it's just going to be on a histogram stuff. You're going to have one problem on it, create a histogram.
This coming Monday?
Not Monday, I guess. So it's still. Is Monday a holiday?
Yeah.
No, next Monday.
No, it's the 19th. It's a holiday.
President's
It's the
Day,
Monday
yeah.
after this coming. Yeah. It's a Monday.
Just stress.
That works. You guys still have that?
Maybe next Monday.
Anybody not have that handout from last time? I wanted to kind of finish it up real quick and then get into what that's leading to.
I wasn't here, so it's so looking at me.
Did you move on to it? Someone needed one?
Thank you.
I gotta keep one for me. This is mine.
Thanks, though.
I made enough for everybody, so it's weird. Gotta ran out.
Okay.
So I think last time we didn't really finish the side that says data analysis exercise.
Somebody got an extra one.
warm up. Let's see. So we talked about this first one. You guys did this first one and you found out that all of them had the same measures in the center. They all came out to be 13. Now, would you say that each group of data is the same? Obviously not. Does that jive with what you found here? No, everything was 13 up here, which is not a surprise because all of these are just one way to look at the data, finding the middle. They're all different ways to find the middle, but they're all ideas of the middle. So here's part 3, when you make frequency distributions. I didn't ask for a histogram here, just a distribution. That's this here. Which one of those is more spread out? Which one gets away from its middle more? So the first one basically lives on the middle, right, with a couple at the ends. So that's the least spread out. This is a little more spread out, right? It gets away from the middle a little bit more. There's only 4 at the middle, and then they get away a little bit. This is what's called a uniform distribution. They all get the same. 2, 2, 2, 2, uniform. Just like wearing a uniform makes you the same as everybody else, right? Supposedly. And then the last one gets away from its middle the most. So we're going to develop today. We're going to actually develop a formula to give us a number to measure the spread. That number would be different for every single one of these. Do you guys get the idea? Because this is much less spread out, and it's a little more spread, a little bit more, a little bit more. So whatever this number is, this will be a little bigger, this one would be a little bigger, and this one would be the biggest, because it's the most spread out. Okay, maybe. So let me give you an example. I guess I should show people that aren't here what we're talking about. There you go. You guys know about that website. You know the one, the Rate My Professors? Yeah. And I remember when we first heard about it, I was teaching on the East Coast. The next day I looked at it, and a lot of my colleagues had gone in and rated themselves, and you could tell. He's the essence of the essence. I'll never forget that one. I knew who that was. I'm like, okay. But do you know that there's another website that will tell you the grade distribution for teachers over the last several years? It costs some money, but it's out there. I'm not going to tell you what it is. Because unfortunately, a lot of you guys want to get the person that gives out nothing but A's, but then you take my class next, and I'm the evil person that wants you to know shit. So there is a website that does that for you. So let's say that you look up 2 teachers, right? The Rate My Professors, they're all the same. And then you go to the grade distribution, and they both give an average of a C, right? The middle is like a C. But the one teacher, let's say you're at university also. Do you guys realize that university, or, once you transfer from here, a D is passing? Do you guys know this? Here, a D doesn't transfer, does it? A D is passing at a university or a 4-year college. Yes. So you could be driving across bridges made by engineers who got Ds. Oh, shit. Yay. Haven't done, yeah, exactly. Normally not, but, so let's say that you're at university, and both of these teachers give C's. But the one teacher gives a range of B through D, so that's a spread, and the other one gives a range A through F. Now, which one would you rather take? It depends, right? And this is true. This happens. If you know you're going to kick ass in that class, are you going to take the one that only gives B through D? Are you sure? I would be pissed. In fact, I lived this experience. The highest grade, I got a B. Guy's waiting for God that takes the class. Whatever. Still give him an A-. I would take the A through F because I'm not concerned that they fail people, because I'm like, give me the A that I know I'm going to make. Now, if I think I'm gonna do horrible, then I'm going to take the guy that seems to never fail anybody. I'll get my D and keep going, right? Do you guys understand what's happening? So that's one little idea of how the spread is useful, how it helps us make decisions. All right, maybe. So let's get into how do we develop, what do we do to get this number? How do we create this number? It's going to take a little. This is. Oh, you're good. You're just stretching. Real quick before I get too far away, our first test is actually, sweetly enough, on Valentine's Day, right? Which is a week from today. So instead of like a quiz, you'll like this. So instead of a quiz, we will have like a little group work thing for Instagram. I'm also going to have a practice test. But I might email out if I remember, and I'll have an answer key for it on Monday. Because the test is on next Wednesday. No quiz. Yeah, no quiz on Monday. The reason I do that, I never give a quiz right before the test because then it's not useful to look at to get ready for the test. Does that make sense? And you're all like, it means no quiz on Monday, whatever you just said is fine. Okay. Valentine's Day is just coming really fast for some reason. All right. So let's actually use the data we have up here. Why not? Let's see. Because it's a lot. Yeah, let's make something. Okay. I just want to do this semi-quickly. Let's say I have these two sets of data. Data set A, let's say, is this here. And data set B is... Now this is going to be a very subtle difference, but that's okay. Which one is more spread out? And we are deciding that, or you are deciding with me, that spread means how far away from the mean do they get on average. The average distance from the mean to every data point. That would tell me the spread. Right? The mean gives me an idea of where the center is, and the spread should be kind of based off of that. How far away from that center do they get on average? Say again? What do you mean it's the same?
It's the same distance from the 3 to 1.
But every data point.
Oh,
Here it's got 3 that don't get away from the mean at all. And you guys see the mean is 3 for both of these? Is that cool? And here you got just one of them's on the mean. This has got a few more data points that get away from the mean. So its number should be a little bit bigger because it's more spread out. How are we doing so far, man? So the number we're about to create measures the spread, which is the average distance from the middle. So if I have data that gets away from the middle more, or further away from the middle on average, that's going to have a bigger number, a bigger this thing that we're going to calculate. All right, have a good one. Now, let me ask you this. The spread is the average distance from the center, from the mean. You with me? Is that cool? Does that make sense for the spread? Do you like this or something? Or like this? Or I love you guys. So the spread. So I got a middle. I got the center, the mean, right? We're going to agree that the mean kind of wins out. It's the most often useful number. So we're going to use the mean mostly. The spread will be how far away from that middle the data gets on average. So if my mean was 10 and my data goes from 9 to 11, that's really kind of like, oh, that's going to have a very small spread. But if my mean was 10 and my data goes from 0 to 20, that's going to have a much bigger spread, isn't it? Okay, you guys starting to be with me? So the spread, let me say it again. Sounds like a note. Anytime I go really slow, it's a note. The spread is the average distance from the mean to all the data points. Okay. So I want to find an average distance, right? That's the base. That's the heart of it. So how do I find the average blank? If I want to know the average male height in this room, what would I first have to do?
Find the mean.
That's what I'm trying to do. In order to find the average male height, the mean male height, I have to first get all the heights. Thank God. Thank you. Right? If I don't have the heights, how in the hell am I going to get the average height? So if I want to know the average, now stay with me. Some of you guys are like, God, just tell me how to do this shit. That's not who I am. I'm sorry. If you want that shit, go somewhere else. I am a explainer. It's too bad. If I want to know the average male height, I got to first get all the men's heights. Obviously. Are you with me? I like it. You guys are like, that's too basic. If I want to get the average distance from the mean, I better first get a bunch of distances from the mean. I better see how far away every data point is, and then I can average them up. So, let's do A here. So this is for group A. So I have 1, 3, 3, 3, 5. You suck, go away. And the mean, of course, again, let's say this is a, now believe it or not, I'm going to start off, let's say this is these are populations. Unfortunately, we often think populations have to be big. No. Populations just have to be everybody I want to look at, and here I'm just looking at 5 people. Everybody cool with that? So what symbol do I use for the mean? We said it was 3. What symbol do I use? Mu. I like it. The little French count. Mu. And the mu here is 3 also. So what did I just say? I said, so a lot of this is going to be derivation, yes, and I'm going to force you to go through this. We're eventually going to make the formula that you just plug shit into and get the stuff. But you've got to understand where it comes from. You've got to understand what it means. I want to get a bunch of distances from the mean. Well, what mathematical thing determines how different two things are? Subtraction. I like it. So I'm going to take the data point minus the mean.
Wait, how do you find the mean?
Oh, add them up, divide by 5. 6, 12, 15, divide by 5, 3. Cool. And do you see how it's symmetric around 3? Both of them? So it's kind of like real quick to see it's 3. So what would it be then? It's going to be 1 minus 3. Negative 2. Is everybody cool with what's happening? 3 minus 3. 0, 0, 0. 5 minus 3. 2. Now, what's bad here in a way? I mean, if I add these up, what am I going to get? I'm always going to get 0 because the mean is the middle of all the values. It's always going to have the same amount negative as positive above and below it, right? So it's always going to add to 0, and that sucks. I can't just add these up and divide by 5. It's always going to be 0. It's not going to tell me that one is bigger than the other, more spread out. Are you guys? So one thing we could do that we don't, is we could take the absolute value of this. And one quick reason why we don't, is anybody remember what an absolute value looks like if you graph it? Bam! Because it's a line that says, oh shit, it can't go negative. So it just turns. You do not want to be on this plane, right? Oh, you're all dead. Can't survive that acceleration. Boom! So that's a horrible graph. It's got a lot of problems right at that kink. Bam! So we don't like that mathematically. It doesn't jive well with a lot of what we want to do in math. There's more to it than that, but there are reasons that we don't just use absolute value. What's another way to make everything become positive always? Instead of absolute value, I can just square everything. Square root of this would suck, right? So it would become imaginary. Let's not bring imaginary into the statistics. So I could just square everything. Now, what does that mean I'm going to have to do at the end? Square root at the end. So why am I squaring this? Because I don't want it to be negative, and absolute value has problems. So what I get 4, 0, 0, 0, 4. And when I add those up, I get 8. Now somebody please help me out. Can you guys? So that's 8. What is the symbol for what I just did? What is the symbol? What did I do with these? I just added them up. And what's add them up in statistics? Sum. So the sum of x minus mu squared is 8 for this problem, right? It's very good. When you do these tables, you've got to tell yourself what the shit you just did so you know where to put that into the formulas, right? People try to put stuff where they shouldn't. Now, I know at the end of this, I've got to take a square root because I squared, and we all kind of understand why we had to do that. But if I add them all up, what's the next thing to do to get the average? Add them all up and then divide by how many there are. So the formula in general for this is going to be add up all these square distances and divide by how many there are.
So there's 4 steps.
If you want to try to count steps, you can. I got a little handout too. It's got a completely worked out problem. On the other side is a problem I want you guys to do. So there is a handout with all this to help you out with your notes. This symbol we use for this guy, have I taken a square root yet? No, and we all know I'm going to have to, because if these are dogs, the number of dogs you own, this is squared dogs. That's some freaky little Picasso looking, walking around shit. Right? I don't want, get away from me, little square dog. So I'm going to have to take a square root. So the symbol we use for this has a square on it, which is nice. It kind of reminds us, oh, you haven't square rooted yet. So here's the symbol for, and what this is called. These are deviations. You know the word deviant, right? All right, so deviation means getting away from the norm, the middle, right? This is how far it deviates from the center. So when I do this, it's the standard deviation. But this isn't it yet. This is the standard deviation squared, what's called a variance. And then when I take a square root, that is called the standard deviation. Oh, shit. Hopefully you kind of follow. I want to add up all the distances. That always is 0, so we squared it to kill the negatives. Add up all those distances, divided by how many there are, will be the average distance from the mean. That's what the spread should be.
What is that symbol?
Which one?
That one on the...
This guy?
Yeah.
Okay. Oh, sorry. Let's all practice this together. You ready? Don't just write a little r. I want you to really try this. You start at the belly of the dude and go out. Don't start at that, because then you get something really weird looking, like a sideways 6. So sometimes I'll draw them and they're really skinny. Sometimes they'll be really fat. It just depends on what's happening. Both of those are acceptable. It's like the different ways people have to make a certain letter or a certain number. How do you write the number 4? Probably not the same as somebody else in this room. So any of those are acceptable. And this is lowercase sigma. I told you that he's going to have a thing later. This is big brother uppercase sigma, and there's lowercase sigma. Makes sense. Standard deviation. Let's use Greek letter S. We already did. Oh shit, let's use the lowercase. Okay. That was the actual conversation. So let's plug this stuff in. So how do I get the variance? It's what goes here. What goes for this whole damn thing? Don't plug something here and here. That's crazy. What is the sum of these? We know what it is. It's freaking 8. The whole thing is 8. The sum of all of these is 8. That's what the top needs. And again, like I told you earlier, you see, if you cover that up, what column do you need? A bunch of x minus mu squares? Well, we had a bunch of x minus mu squares, so I can add them up now. And what goes on the bottom?
And?
5. Good. Double of 16 over 10 is 1.6. So that is the what? 1.6 is the variance. And then if I take the square root of that, what is the square root of 1.6? That's like 1.2 something. All right, now here's our first little rounding rule. You ready? You always round. I guess we can leave that guy out. You always round the standard deviation to at least 3 decimal places. At least 3 decimal places. So tell me again. 1 point. 2, 6, 5. Okay. About. So if I did all this again for this data, would it be bigger or smaller than 1.265? What does that measure? It measures the spread. And then we say that this was more spread out. So if I do all this again, the number I get for B would be a little bigger than 1.265. Now, just to kind of lay the groundwork here, the reason we calculate this is, number one, is incredibly useful. I gave you one example that wasn't even really mathematical, but it was the B's, D's, A's, C's, F stuff. And number two, it gives me a natural way to measure distance. So like, if I wanted to measure the distance between 2 people in this room, would I use miles?
No.
Oh, hell no, because the spread of people in this room is relatively small. But if I wanted to measure the distance between 2 countries, then I'd use miles because the spread is much bigger. So calculating the standard deviation gives me something to use to measure distance, and that's going to be like the next level of this, is how do I use this? Okay, so let me give you this handout. You guys can work together on this, or not. It's entirely up to you. This is not a quiz or anything. One side is completely worked out, so don't just sit there staring at it. I'm all done. No, the other side is blank. This is for you to work on. Oh, okay. Right. I kept trying to remind myself. All right, so this, what kind of letter is this? Is it our letter? It's Greek, right? And that was Greek, and that was for a population. So what we were working with there was populations. So bear with me for a second. There is an adjustment I make for a sample. All right, so I'm going to try to explain it semi-quickly. There's one little difference between the formula I have up here. Besides just the mu is now an x bar, but there's another difference on the bottom. So let me ask you this. There's an average age of everybody in this room right now, correct? Okay, if I take a row, if I just pick a row at random, is their average age going to be the same as the average of the room? What do you think? I'd put money on it not being, and I don't have much money, so it says something. Yes, more than likely, the average of any group I take is going to be different somehow. Are you with me? The people in this row, will they overall be closer to their own average or to the average of everybody? They're obviously their own, because that's where their own average would come from their values. So when I do a sample standard deviation, it's always going to be smaller than it should be, because a sample will be closer to its own mean than it really should be for the whole population mean. Let me let that sink in. And again, you don't have to understand everything about all the ideas behind everything, but I'm going to put it at you anyway. So does that, again, they're going to be closer to their own mean. So the standard deviation I calculate for this sample will be smaller normally than it would be for the whole population. Does that make sense? Because they'll be closer to their own mean. So if I have a sample, one thing is I don't use sigma, I use S. Remember, if it's a population, it's mu. If it's a sample, it's x bar. If it's a population, it's sigma. If it's a sample, it's just S. So one thing is I use S. Another thing is I have x bar here, right, instead of mu. And then finally, how do I make, if I divide something, how do I make it bigger? Because their standard deviation is going to be too small, because they're closer to their own mean. So how do I make it bigger? I divide by less. If I divide by less, doesn't the result get bigger? So instead of dividing by n, I divide by n minus 1. Now, believe it or not, that adjustment makes it perfect. What it does is, if I took every possible sample in here, calculated all the variances, and then averaged them, it'd be the same as the population variance. If I don't do this adjustment, nope. It doesn't target that. That's what we call it. We say it targets that, but it wouldn't. So this is just an adjustment for if it's a sample. And what do we mostly use in statistics?
Sample.
Sample. So this is the one you're almost always going to use. Okay? if you don't, I'm going to make it really clear. I have a population. I'm going to probably put that in bold because that's a weird thing to have in statistics. So it's the same exact idea as this, except instead of dividing by n, you're going to divide by n minus 1. I like it. So go for it. Yeah. Let me turn this dude off.
Is that going to be